Hello, this is part 3 on the section about difference equations modeling. We saw the population growth example with the wildebeest, and now we want to get back to the medication example that we've just started talking about at the beginning. And so we're going to look at a specific medication called atenolol. It has a half-life of about 6 hours, and we're going to have some options for an initial dosage and a maintenance dosage. And what we want to do is we want to model the amount of atenolol in a person's system each day under those conditions. And then there will be some other questions we can ask about equilibrium and what's the range of the medication in the system for each day. So let's start off with A sub n equals the amount of atenolol after n days. Notice we could have maybe done 6-hour periods for our time frame, but for this particular example, we're going to focus on days. A naught will be the initial dosage, and D is the letter we'll use for maintenance dosage. And so we're interested in how do these variables affect our overall level of the medication in our system. Now, if we wanted to go through the full modeling process, we could think about what are all the variables that affect how that medication behaves and how long it lasts. That would be a complicated thing. Probably would need to do some research or talk to some experts about it. But for this particular problem, we're given the assumption straight up, so we're not going to have to go through that. But it is worth thinking about that it's more complicated than what we're given here. But this is a starting point. And so what this allows us to do then is to immediately write down this statement in terms of a difference equation. Because half-life, if you think about it, is basically an exponential function. It's telling you that your change is half of what you had before. So after 6 hours, you're going to lose half. But that's in 6 hours, and we're interested in a day or in days. So there's 4 6-hour periods in one day. So then the question is, all right, well, how much do we have left at the end of a day if we haven't taken any additional medication throughout the day? So if we have 50% after 6 hours, then after 12 hours will be half of that, so 25%. After 18 hours will be half of that, 12.5%. And after one full day will be half of that, 6.25%. And keep in mind, this is what's remaining. So what that means is that we've lost, 93.75% of the original. So that's the change for our model. So in other words, this is our R. So if we want to model how the amount of atenolol in our system has changed, it's R, or in other words, a negative 0.9375, because we've lost, so that makes R a negative value. We've lost almost 94% of what we started with. Now this isn't quite everything though, because notice every day, presumably, we're going to be taking a maintenance dosage. And so we're going to add a D. Okay? And then A naught, of course, is going to equal whatever we decide for a initial dosage. So here's our model. And now we want to see it in action. So let's do a specific example. Let's say D is equal to 100 and A naught is equal to 50. So what that gives us then is A sub n plus 1 minus A sub n, right? That's our change, is negative 0.9375 A sub n plus 100. If I move this over, that's adding 1. So I have A sub n plus 1 equals, notice, 1 plus this negative number is 0.0625 A sub n plus 100 with an initial value of 50. And so here's our model for this situation. The nice thing here is that we're seeing that we are retaining 6.25% of what we started with. So that matches with what we expected. And of course, we have our initial value. And if we put this in a spreadsheet or a calculator, this is the results we get. And so sure enough, in terms of an equilibrium, what equilibrium is achieved, it appears that we're getting an equilibrium of about 107. So the equilibrium is approximately 106.7 milligrams. And then the max and the min. So the max is at 106.7, and then the minimum, it depends a little bit perhaps on when you're taking the dosage, but the minimum, then of course, that 106.7 includes the additional 100 that we add at the end of the day, and so the minimum then is about 6.7 milligrams. So we can see that once we get into this equilibrium stage, we bump up to about 107, drop down to 6.7, and then bounce back up. Now, if we want to see how those numbers would change with different values of A naught and the dosage, and we could even change the half-life too, then a spreadsheet is the way to go. So let's take a look at that now. All right, so here's our spreadsheet. And as you recall, we started with 50 milligrams. And our R was, as you might recall, 0.5 to the fourth power minus 1. And our D was 100. And our model was basically the initial amount plus this times the initial amount plus our maintenance dosage. So this is giving us the amount in our system after we have taken the pill. All right, I need dollar signs there because I don't want the E1 or the E2 to change as I drag it down, right? So notice as I drag it down, this has become B9, just the way we wanted. And that's B9, but E1 and E2 have remained constant. And so notice it doesn't take very long at all to get to that equilibrium. If I change this to say 200, again, in a few days, I'm basically at that equilibrium. If I change this to 0, again, just a few days we reach that equilibrium. And notice the initial amount does not change the equilibrium. So those two are independent. But that maintenance dosage is different. If I bring this down to 50, well, now my equilibrium has dropped, which hopefully makes sense. And if I raise this up, then of course it's increased as well. So there's a relationship between the equilibrium and the maintenance dosage. And if we wanted, we could try a different half-life and see that that also is going to make a difference. For example, if it was 12 hours instead of 6, and I change that to a 2, then notice that's also going to change things. All right. So the thing we would want to keep in mind then is if I want my medication level to be higher than, say, 6.7, but lower than whatever would be unhealthy, then what sort of medication plan would I want to maintain a healthy equilibrium within the range that I need? So you can play around with those numbers more in the exercises, but for now, that's all we have. So we'll see you in the next video.